Hi, everybody. I'm Mike Glass with Orion Technical Solutions, and I'm going to go over a little tool, converter tool. It's a little simulation that I've got set up that we're going to be sharing with people. I'm going to explain kind of how it works and how you can use it. Basically, what it's used for is converting um, across a transmitter. So converting an input to a milliamp, converting a reading a milliamp output of a transmitter to see what that corresponds to on input, and determining the percent of span errors based on that. So basically, to jump right into it, I've got a transmitter. I'm going to say that the range is 0 to 200 degrees Fahrenheit, and I've got a tolerance of 0.25% of span. So pretty tight tolerance there. First, I'm going to do the engineering unit to milliamp. So basically, I say, well, I happen to have my little simulator or an RTD that's plugged into a known source, a dry block calibrator or something, and it's at exactly 100 degrees Fahrenheit. Well, if that's the case, the transmitter should be at 50% of span. That's what I should see on the transmitter PV display if it's a smart transmitter. And it should have a milliamp output of 12.0 milliamps. If I happen to have a 11.98, I'll change that a little bit. Let's say we have 11.95 uh, milliamp output. That's a fail. It's not within the tolerance. Well, how close is it? Well, we're minus 0.05 milliamps from where we should be. That comes out to equate to 0.625 degrees Fahrenheit, and it's 0.3125% of span. The limit for that would be uh, zero point zero 0.04 milliamps off. So I knew that when I typed it, so I just wanted to show you that. So that right there is kind of handy. Let's switch it around. Instead of going from engineering unit to milliamp, sometimes we're out in the field, we see a milliamp reading, and we kind of need to know what what is the input that should cause that. So I'm going to say that I'm out in the field and I see 13.13 milliamps. Well, that would correlate to 57.0625% of span. It would equate to 114.125 degrees Fahrenheit on the input. And let's say that I actually have 114.5 degrees Fahrenheit. Well, that's a pass. And again, it'll do the same thing. It'll tell you you're within, however, the temperature, you're within 0.375 degrees in this case. You're within 0.03 milliamps of the proper reading for that correlation. And it's a 0.1875% of span error. So pretty handy both directions. It'll tell you if you fail, pass, whatever. The other thing that's cool for this is it'll show you what your engineering unit and your milliamps should be, the tolerance for each at each of the common checkpoints. So it goes 0, 10, 25, 50, 75, 90, and 100. A lot of situations people need to check those 10 and 90s, so not everybody does that. Some people only do the 3 point checks, which is all, it varies. So but if you need it, it's there, and you'll notice that changes. So I come up here and I change the EU value from 100 to 200, and maybe or from 0 to 200. I'm going to change it now and say 200 to 500 is my range. Well, in that case, it's going to scale it for you. It's all right there. So pretty handy. I do have a calculator in here. Long story on that. That's for some of the stuff we do with some of our students when we're giving them challenges. We turn off the calculation function and they have to calculate it. So it's a good thing to know how to do manually. It's also good to have a tool to back you up. So that's what we're trying to do. Hopefully this tool's useful. If you like this, we got a whole lot more of these coming in some of our new programs. So we're trying to make it easy for people to learn by doing and by seeing stuff and playing with it. That's how you learn. So that's how we do it. Hope you enjoyed that, and we'll see you again soon. Thanks.